the carbon dioxide thing, but thank you.
Okay, yeah, we'll move on in the interests of time. Next talk. Welcome to the stage, Judith Kinnaird, who's going to talk to us about the Bethal lobe of the Bushveld. Judith.
I feel in the context here, I should be talking about the northern limb, but I'm going to take you elsewhere. I hope you've all enjoyed being in my home city. I don't think there's very many people in the audience here who can say that Cardiff is their home. So I only need half an excuse to come back, added to which my son and granddaughters live here. So I want to, I got a point from there. Great. I want to look at the Bethal limb, because it's really the last frontier. Is there going to be something worth mining here or not? We don't really know. So we've got this far western limb, which has been mined, but it's very different from the western and eastern limbs. We're just hearing quite a lot about the northern limb and the far northern limb up here, the Waterberg, which hasn't been talked about much. Which has been talked about this afternoon, but is quite late coming to join the party. And even later to join the party is the geology of this Bethal limb here. It's been known about for decades, but the thing is that very few people have drilled it because it's very much covered by, Karoo, sediments. So if we look at the magnetic and gravity maps of the Bushveld Complex, you can see that this Bethal lobe here, Bethal limb, seems to be continuous on both magnetic and gravity data. And I want you to focus on the Stoffberg area, which is just up here, with the layers drift fault that I'm going to mention. Now, just for those of you who are not desperately familiar with the Bushveld stratigraphy, we've got a lower zone, it's at the bottom, and it's ultramafic. You've got a critical zone, so-called because that's where all the critical metals came from, the chromium and the platinum group minerals. A main zone, which somebody here has called boring, with which I don't agree, and then an upper zone. And we can see the difference between these quite readily on some geophysical plots, etc., because the upper zone is stuffed full of magnetite. In many places, there's up to 21 magnetite layers. In other places, as in the Waterberg in the far north of the northern limb, there's no magnetite layers, but it's stuffed full of magnetite. Then when we have this main zone here, the so-called boring gabbro-norite, and then lower down the norites, that's magnetically very, very low in magnetic susceptibility. And then the critical zone varies depending on how much mineralization there is. So going back to 1969, a guy called von Grunewald identified that there was main zone and upper zone rocks in this Stoffberg area, but there was no critical zone rocks identified. And so he concluded at the time that there was no potential for mineralization, no potential for finding a Merensky Reef or a UG2. Nevertheless, people pursued the idea that maybe there was these horizons, and then exploration took place sporadically in the 1970s, in the 1980s, and in the 1990s, based on these maps, which showed that the Bushveld Complex did continue under the Karoo. Now, there is this Stoffberg area here, and if we look at it on the maps here. Here is the Slayers Drift Fault and Stoffberg here. So this Slayers Drift Fault seems to be quite important because to the north of here, there are a number of farms. The areas are named by a farm name, and you can see some arrows there of Cliprivia pointing down to Middle Crall in the south, just beyond northwards of the Slayers Drift Fault. And there was a project by one company on this Cliprivia's Clipbank Strait area, and they indeed found they found the Morensky Reef and the UG2, both of which had grade. Then, can I get me that spot again, please? Then John Davenport and a small company investigated the area to the south, and they looked in the area from Houghton Beck to Middle Crall, and actually Paul and myself actually helped them. And they also found Morensky Reef and UG2. So there was a lot more interest now in, well, what happens when we go to the south of this Slayers Drift Fault. This map is from Jan van der Merwe, who Ian referred to having done fantastic work in the northern limb. He's also done fantastic work over in the southeastern limb here, and has worked also with Rice Latikov, producing this map fairly recently. Jan van der Merwe did his MSc at Wits, mapping in the northern limb of the Bushveld Complex, and then trained as a dentist and spent all his life as a dentist, and did maps like this over here in his summer holidays. So then Buchanan came along in 1975, and he had a borehole down in the Bethal area, and in it, he found at the base pyroxenite peridotitic rocks, which he concluded was equivalent to the lower zone elsewhere. But then surprisingly, above that, what he found were rocks with magnetite in. And he divided this package of magnetite rich rocks into 4 zones, the top 2 which have magnetite layers, and the bottom 2 of which were stuffed full of magnetite, but didn't actually have any layering. So on the basis of this, Buchanan concluded that critical and main zones were missing in this Bethel area, and that was supported by Moose Kruger, and he's probably not going to like the rest of the talk. But no, you're not allowed to ask a question, Moose. We can fight later. So Buchanan then concluded that these critical and main zone rocks weren't there, so that there was no potential. However, the story continues, as it inevitably does in geology. The map on the left here is from a paper by Ian Basson looking at the whole of the Bushveld Complex. But I just want to focus on this area here, which Paul and I have had a good chance to look at. So south of this Slayers Drift Fault, indeed the Bushveld intrusion is there. And based on a number of different parameters, we saw this as divided into 3 separate subchambers. In the north, the Belfast subchamber, which is about 50 kilometers long, between Stoffberg here and the Wonderfontein Fault here. Then a Hendrina subchamber, which is about 40 kilometers across, and then a southern Evander or Leandra subchamber, which is about 80 kilometers across. 5 minutes. And so we have the different triangles here are different drill cores. And if we look to the north, in this subchamber here, we have 6 cores which are coloured in Bushveld lithologies. We have the holes here which are coloured in Karoo, and then these 5 cores in the south which are also coloured in Karoo. So I'm taking just one of these boreholes up here, showing you that it's in gabbro-norite, going through an orthosite and norite down to a pyroxenite, which has got some grade in. And this boundary here, 120 to 100, this area here, is taken as the boundary between the main zone and the upper critical zone. So if we look now at the magnetic susceptibility over here, the scales on these diagrams are not necessarily the same, but you can see that we have a fairly low magnetic susceptibility until we get to 250 meters depth. And you can see that in this area as well, we've got very high nickel, and we've also got 2 high levels of chromium concentration. Taking a hole from Hendrina, we are now have our holes coloured in Karoo supergroup, but here we have thick packages of gabbro-norite with interlayered metasedimentary rocks of the Karoo, including some coaly horizons. And we have the main zone upper critical zone boundary here. And again, we see the same pattern of, in this sort of mineralized zone, we get peaks of nickel, chromium, copper, and platinum plus palladium and gold. But these levels of platinum, palladium, and gold are very low, something like 0.8 grams a ton, and up to 0.8% copper and slightly lower nickel. In the south, then, the holes are all coloured in Karoo, and below that we have upper zone. And what we're showing here is the magnetic susceptibility for this hole, which is over there, this hole, which is here, and that hole, which is there. And you can see the magnetic susceptibility meters just gone mad throughout this area. So this is all regarded as upper zone. However, Sue and Carol, my geophysics leaders, said, but look at this bit down here. That looks to us as though you've gone into main zone. I hadn't thought of that, so thank you, Sue and Carol. There's no lower zone here because the boreholes aren't deep enough. But if we go over to a hole slightly to the east, work done by Buchanan in 1975 showed that the top part was all upper zone, but beneath that, there was a package of peridotite, Hartsbergite, pyroxenite, but it was much deeper. The hole goes down to 1290 meters. So maybe a lot of these other holes, such as the one I was just showing you, the ones I was showing you a few moments ago, with this thick upper zone package, maybe they didn't go down deep enough. Now, 1 minute, I'll be 2. We've got this A-B cross section, which is shown here, and then the CD cross section, which is here. The AB is just as I've shown in my holes. This is from Buchanan, with upper zone resting directly on transvaal metasedimentary rocks. Whereas this hole here recognizes that there are ultramafic rocks at the bottom, which has been correlated with sorry, I've lost track there. I'll move on. So one of the things that as we look for the holes from north to south, we see the same sort of patterns. We see multiple layers that are rich in chromium or nickel or copper. And one of the things that this means to me is that we've got multiple phases of magma flowing into this chamber. The thickest is up here, where we have 1,500 meters of main zone, 1,200 meters or more of main zone going down into upper critical zone. So in the north here, we seem to have upper main zone and upper critical zone. And then down here, we have upper zone with all the magnetite and lower zone. So where did the magma come from? Did it come from the north, losing grade as it was coming southwards? Did it come from the south east? A lot of people believe there was a chonolith from the Outcons complex, or more recently, my geophysical colleagues have suggested that it may have come from this sugar bush fault, which opens in a whole new sort of kettle of fish, because originally I was going to say that this data that we've got might suggest that the Bethal limb wouldn't appear to have any significant economic potential. But if the magma does come from this sugar bush fault here, then maybe it does. So thank you very much. Diolch yn fawr.
Probably no time for a Moose question, unfortunately. Has anyone got a very quick one while we do the changeover? Yes.